Welcome to MyProjectBazaar.com.
Project title is Joint Spectrum and Power Allocation for Multi-Node Cooperative Wireless Systems. Next one is abstract. In abstract, energy efficiency is growing concern for wireless network, not only due to the emerging traffic demand from smart devices but also because of the dependency on the traditional unsustainable energy and the overall environmental concern. The urgent call for reducing the power consumption while meeting the system's requirement has motivated increasing the research efforts on the green radio. In this paper, we investigate a new joint spectrum and power allocation scheme for a cooperative downlink multi-user systems. Each user equipment with the assumption that multi-BS UA, then user being served by the multi-base station, would require the same amount of spectrum from these base stations. We conclude that when the number of multi-base stations UE is limited by the M-1, the resource allocation scheme can be always guaranteed to minimum the overall transmit power consumption while meeting the throughout requirement of each UE and also each base station's power constraint. Then to decide the clusters of multi-BS UE and the clusters of the individual BSU using be served by the individual base station, we propose a UE BS association scheme or complexity to the reduction scheme. Finally, a novel joint spectrum and power allocations algorithm is proposed to minimize the total power consumption. Simulation results are presented to verify the optimally of the derived schemes. Then joint spectrum and power allocation scheme to improve the system performance and make the best use of system resource. Cooperative transmission have recently attached the basic idea of to take advantage of the broadcast nature of the wireless communication such that some nodes in the wireless network can help each other to transmit the signals for better quality via spatial diversity or higher data rates through the spatial multiplexing. The next generation cellular networks, including the cloud radio access network and the software defined wireless network, have proposed to enable the cooperative transmission through the baseband unit pole and the controller, one typical technology that has already have been adapted by the 3GPP. Long-term evaluation is a coordinated multi-point transmissions. Next process will be the simulation, that is flow diagram. In this flow diagram we have to node deployment will be there. Node deployment we have to insert the IP address, MAC address, queuing address, that and all we have to give us a node deployment. Network formation overall parameter we have to give number of nodes we have to use this and routing protocol, thus and all the network formation. Next is cluster formation. In cluster formation we have to get the cluster head selections. Next is a in this cluster head selections we have to use a process will be the cluster head selection will be the highest energy efficiency. We have to select as a cluster head. Then the process implementing the USB scheme implementations. In this implementation process we have to find out the data transmissions and the analyzing results. In the analyzing results we have to quality of service parameters and throughput, delay, that and all the quality of service parameter we have to analyzing in the results during the data transmissions. After that we have go for the simulation. Open the roots home and the type product 12. Open the this one is CD space product 12. Next will be the ls that main.tcl, and then main.tcl we have network format. Next will be the cluster will be formed. Cluster head we have to select it, and then base station will be used in this base stations. After that the data transmission will occur in between the cluster members and cluster. After that cluster head to base station, this will be the data transmission will occur in the cluster head process. That coverage of the circle will occur. No, that circle will be there. Each and every node coverage area it will be declared like this. So we have to use as a cluster formation and cluster head selection in data transmissions. Next one is a the simulation will end on after the 100 millisecond. This will be the ended. After that we have to go for the graph generation. After we have to type a ls then awk minus f delay dot awk, it compared with the out trace, that is output file. It will be compiled, automatically the xgraph will be generating. So xgraph delay dot xg, this will be the delay graph. It will be randomly, it will be decreasing like this pulse form, it will be declared. Next one is a awk, it will be compared with the throughput. In this throughput x graph throughput dot thr dot xg, these will be the throughput file. Then next is a packet delivery ratio. In packet delivery ratio, it will be the we how much packet we have to send this, but not the receiving packet will be the 0. So graph will not generating. So x graph the packet pdr.xg we have to deploy, it means the packet will not occur, because the sending packet 87 but receiving packet is not getting any receiving packet. The percentage of the that's all. In this pdr dot how much sending line and receiving line, that will be the pdr file.